Hey everyone, we are going to move on to our trig unit, and we're going to start doing some work where we're going to start finding some sides of our right triangles. And we're not going to find sides using Pythagoras now. We're going to use find sides by using some of our trig ratios. And we're going to use a lot of the skills that we developed before this lesson to move forward. But I want you to know that when you're solving trig ratios, it's just like solving other ratios that we've done in the past. So I thought we'd start with an example. You've got $3.75 and you can buy 25 pieces of candy. What does it cost you for one candy? So when we do a question like that, we like to use ratios. I didn't put my dollar sign in, I didn't put candies in, but it's dollars per candy. How much money does one candy cost? So we know we can cross multiply 375 times 25 and then divide by the 25. And we can get an answer that every piece of candy is going to cost us 15 cents. So that's using ratios, and that's kind of going back to unit pricing like we did a previous chapter ago. The second question is, how many pieces of candy can you get for $9? Well, same idea. We can use ratios to figure out our problem. The thing now is we actually have two ratios to choose from. We can use the original ratio of $3.75 for 25 candies, and I have $9. How much can I get? Or I can use the simplified ratio of 15 cents for one candy. How much candy can I get for 1 cent? And it doesn't matter which ratio we use, we're going to get the same answer. And this is the part that we use in right triangles, sine, cosine, and tangent, is the idea that we've got equal ratios to solve the problem. So it doesn't matter if I'm going to cross multiply 25 times 9 divided by 375 or 1 times 9 divided by 15 cents. I know that when I'm finished, I can buy 60 pieces of candy. So ratios that are equal to each other, we're going to cross multiply and solve. Okay, so now we're ready for trig. So our trig question, and this looks a little bit different than your question, but these are the steps that I want us to go through. So when we kind of look at the information, I said, I want you to start off by labeling the sides and circling the angle. Well, the angle we're talking about is the angle 34 degrees. So I'm going to circle my A. I want to make sure I know which my hypotenuse is. So I always look at my right angle and I go across from right angle, and that becomes my hypotenuse. The side that is opposite of A is like a projector again. 34 degrees is my projector, is projecting all the way over here to the side where the X is. So that is opposite of A. The side that's missing then is the side that's opposite B, or the side that is called adjacent to A. So when we're going to solve trig problems, we want to know what angle we're talking about, and we want to know that we can label the three sides properly, just like you did when we were doing the questions before. So the next thing we're going to do for the first few examples is we're actually going to write out what the three ratios are: sine of A, cos of A, and tan of A. So again, we label the triangles. We've got three ratios. We want to write those three ratios out. What's different this time, though, instead of saying sine of A, I'm going to say sine of 34 degrees, cos of 34 degrees, and tan of 34 degrees, because I was given that angle A is 34 degrees. And opposite over hypotenuse is just like you were doing before. Opposite is X, hypotenuse is 8. So sine of 34, opposite over hypotenuse. Cos of 34 is the adjacent side. Well, I don't actually have an adjacent side. I don't have anything here. So if I was to put something in there, I would put in a little letter B, because that's the side that is missing in terms of the side that's adjacent. So when I say adjacent over hypotenuse, I'm going to put B over 8. And when I do tangent of A, I want to go opposite over adjacent. I'm going to put X over B. So the next thing I want to do is make my ratios into decimals. So and this is the last lesson that you did. You made sine 34 a decimal, cos 34 a decimal, and tan 34 a decimal. So that's why I had you do the skill changing your ratios to decimals. The thing that's different here is I've put all of our decimals over top of 1. The same way we did the candy example, 15 cents for 1. This is 0.5592 over 1, 0.8290 over 1. So if we don't have a bottom number, the bottom number in the ratio is 1. So now the question is, which ratio should I use to solve my problem? Well, which ratio can I cross multiply with? If I want to solve for x, I can't cross multiply and have x and b in it because I've got two things that I don't know. I don't know x and I don't know b. I can't use this example. I can't use cos 34 because x doesn't even exist in this example. When I come back here, I look at the sine ratio. This is like doing my candy question. I have the numbers that I need to cross multiply. So I'm going to cross multiply. I'm going to multiply the 8 times by my decimal, 0.5592, and then divide by 1. And then I get my answer, which is 4.5. So all the skills that we were working on for the last 10 days, how do you label sides? How do you write ratios? How do you change ratios to decimals? That's what we're going to do. This is how we're going to solve for sides in a triangle, sides in a right triangle, when you know a side and an angle. Okay, we're going to stop this lesson here and make a second video for our next examples.